Good afternoon. Sorry I couldn't be here. Had to be elsewhere. So, you've got a test tomorrow. What you should know for the test. You should probably take out your notes and get ready to write this down. I'll give you a minute. Hope you're ready, because I am. Here we go. Some things you should know. Terms. If you don't know your definitions, if you don't know what a word means, then clearly you can't answer a question that contains that word because you won't know what's being asked. So some things you should definitely know. Know what the term stoichiometry means. That's in the first page of your stoichiometry notes. Know what molar ratio is. That's that ratio that we get from the balanced equation. Know what limiting reactant is. Keep in mind that the limiting reactant is a reactant, not a product. So if you're writing down a product as your limiting reactant, it's going to be incorrect. That should be a big red flag. The official definition is it's the reactant that runs out first or that gets used up. Completely used up. Of course, the way we find it is that we figure out which reactant makes the least amount of product, but that reactant that makes the least amount of product is the limiting reactant. So be sure you read your questions carefully tomorrow. Know what excess means. That would be your leftovers, what isn't used up. Back to that ham sandwich example. 5 slices of ham, 20 slices of bread, and with the recipe of a ham plus 2 breads gives me a ham sandwich. This I would be able to make 5 sandwiches. Ham is limiting. That's what I'm going to run out of. And my bread would be my excess. That's the one that I would have leftovers of. How much bread would I have left over? Well, I'd make 5 sandwiches, so I'd use up 10 slices of bread. I'd have 10 slices of bread left over. Okay, so excess. That's the extra, the leftovers. What else might you want to know? Percent yield. That's actual over theoretical times 100, in which case you should probably know your actual and your theoretical. Actual yield, theoretical. This is what's measured in lab or given in problem. You know what, I'm not going to say given because that makes us think something else. So I'm going to say supplied in the problem. It is always a product. Just like a limiting reactance is always a reactant, one of the reactants, one of the things on the left side of the arrow, an actual yield, the number for the actual yield is always going to be a product. It's always going to be on the right side. And it's typically what you're going to use as your unknown. Oh, let me back up for a second. Limiting reactant, two givens, unless you're told which reactant is excess. Because if you're told something's excess, then it can't be the limiting. It doesn't run out because you've got extra of it. Theoretical yield, that is your Stoich calculation. All right, know those terms. What you should be able to do. Yeah, let's go down here. Hopefully you're keeping up. Be able to solve mole-mole problems. That would be stuff like, well, I'll give you some examples in a minute. Let's do this. Mole-mole, mass, volume mass, mass volume, volume. What do all these mean? Well, what they mean is that in a mass problem, or a mole-mole problem, or any of these problems, this is my given of some material. This is my unknown of some other material in the balanced equation in my reaction. One of the things that we used to help us do these problems was this guy right here, the stoichiometry mole road. We started out with mole-mole problems. That's where we went from moles of one thing to moles of another. You can start here. You could possibly start a problem in the middle. This whole side over here, as you can see, would be my given side. I could be given mass, I could be given volume, I could be given moles. Remember, we chopped off the top part of this where we went to representative particles. So I could start in any one of these three. In a mole-mole problem, in a mole problem, I'd go from moles of A to moles of B, and I'd use that molar ratio. This is where that molar ratio comes from. For a mass problem, I'd start in mass, and I'd go to mass. For a volume-volume problem, I would start in volume and go to volume. Let's see if I can get a highlighter here. Whoa. So for a mole-mole problem, I'd start in moles, and I'd go over to moles. For a mass-mass problem, I'd start in mass, and I'd go all the way over to mass. Notice that's like a three-step problem. A mole-mole problem is only a one-step problem. Volume-volume, I'd start in volume, and then cruise over and finish in volume. Again, a three-step problem. Mass volume, I'd start in mass, cruise through moles, over to moles, and then down into volume. For a volume mass problem, I would start down in volume. Well, it's going to get messy. I'd start down in volume, and I'd cruise through the mole all the way over to mass. All right, again, this side, let's see if I can do this. This side is my givens. Over on this side, these are my unknowns. Those givens and unknowns can be anything. They can be products, they can be reactants, just two different materials in the same balanced equation. Oh, that's right. Should mention that. You always need a balanced equation for stoichiometry. Always. It's your first step. Get your balanced equation if it isn't given in the problem already. So that's your mole road. Know this. You do not get to use this on the test tomorrow. You've got to know it. What else should you be able to do? You should be able to do a limiting reactant problem. Again, usually two givens. And you look for the least amount of product. And this is kind of like me speaking with the amplifier, the microphone, only I'm not here this time. And last but not least, I should get rid of this. You should be able to do percent yield problems. Which is really, all the stoichiometry in front of it, and then taking that final step. Now, prior knowledge. What kinds of things should you know already in order to be able to do this stuff? So I would call these related first semester skills. In order to do any of these problems, you need to be able to write formulas. So you would need formula writing. And ions. Where might you find that? That was chapter 4 stuff. You should be able to balance equations. That was chapter 7, 8. You should be able to Identify types of reactions. And or predict products. In other words, take like a single replacement reaction and tell what's going to be made. So something like sodium reacting with aluminum chloride. And what would that make? Well, who would get kicked out? Sodium would be kicking out sodium positive or negative? It's positive, so it's going to kick out the positive. Hence, that knowledge of ions really helps. So that would mean aluminum gets kicked out, and we get NaCl. And then we need a 3 here and a 3 here to balance it up. You should be able to do that. Where was that? Well, that was chapter 7-8 also. You should be able to calculate molar masses. Where was that? Well, that was chapter 6. If you're shaky on any of this stuff or any of the chapter 9 stuff, which is stoichiometry, someplace you might want to go and take a look at is, all this stuff, these resources that I've got out there. I've got chapter 7-8, chapter 6, chapter 4, chapter 9. There's a bunch of videos and resources that should help you. There's all kinds of different problems out there. You can also use, of course, the wish I had asked that in class. If you think of something you want to ask me tomorrow night, I'll try to make sure I'm pretty available to answer your questions pretty quickly. Rest of the period is yours to work on. The stoichiometry pretest. I am going to post answers to this. Actually, you might even have them already. If not, you'll for sure get them at 3, I hope. This is something I was going to show you guys yesterday and didn't get a chance. I'm going to try to use this. This is remind101.com. Mr. Mitchell showed it to me. A couple other teachers are starting to use it from what I understand. What I can do is I can send out text messages. Like I forget to tell you something, I can just send out a mass text message. It's one way. I don't know your phone number from this. All I get is, actually I don't get anything. I send out a message, you don't get my phone number, you just get my message, and then you can't reply to the message. So my intent is, if I haven't done it already, is to send out the answers to the stoichiometry pretest questions that you're working on now. I don't have the solution set with me right now, so I can't really, put the answers up. Otherwise, I would. So what I'm going to do is tomorrow morning I'm going to send this out. I'm going to schedule it to go out at 3, maybe 2:30 during 8th hour. The message should go out. So if you sign up by 2:30, you'll get the answers to the stoichiometry pretest. All you need is text messaging. You don't need a smartphone to do this. So what you do is you dial 630-599. Why don't you guys, if you want, take out your phones right now and go ahead and register right now. Text this at symbol BB3AA. Text that to the phone number here, 630-599-8870, and that'll get you signed up. So why don't you go ahead and do that. Again, I will post the answers by about 2:30. My intent is to get in early tomorrow morning and schedule that those answers be sent out at about 2:30 by text. Okay. Good luck on the test tomorrow. I should get in around 7. We have resource this week, so I should be able to see. I'll see 6th hour during resource. Good luck. Take it easy.